Okay guys, sheet 7 of solids in contact there. So just looking at the 3D here, you've got a cone and you've got a cylinder up against the cone. They're all on the ground, and you've got a cylinder. No, this cone has the axis horizontal, whereas this is the axis vertical, an upright cylinder. So anyway, so it says there, draw the elevation of the cylinder B. So that's B here, lying on the ground. So I would consider this straightforward enough. But when we'll have this front view done, just to look at it there, right, there's your cone A. So I'm going to be bisecting the angle here, because if the cylinder B is on the ground and it's up against the cone, you're always going to be bisecting the angle between the ground and the cone, and then you'll just find where the center is then on here, and it will automatically then be touching the ground and the sphere at the same time. So that's the first thing I'm going to be doing here, but I'm going to take it that people really know that. So I'm bisecting the angle between the side of the cone and the ground. So just swing 2 arcs and then 2 more arcs. And that here is the bisector of the angle. And the next thing now is, if I measure the diameter of that there, it's 22.5 or whatever, but I'm going to be taking the radius of B. So I can take it from the plane here. So the radius of that circle is, I can take it from here. That's the radius, so I can just swing an arc up that height and go across. So the center has to be at that height. So there's the center for my, it's just quicker and easier, I suppose, than measuring it. I could just measure that there and take that height up as well. So there's the center. Stupid in this. There's another easy way of doing it. I could have just projected, because I know where the axis is, the center is, I could have just projected that up as well, yeah. Anyway, there's always a few ways to do these things. So there's my elevation of that. Now, you can see there, like half a mil off or whatever. If you were looking carefully at that there, it's just a tiny bit out. But I would never worry about that. It's your method that matters. Like, you know, wouldn't worry about that. No, it didn't ask for the point of contact, but if I wanted the point of contact, it's 90-degree angle, so perpendicular from the side of the cone through the center. So that there is the point of contact, and if I wanted to know, it didn't ask for points of contact here, but just, there's always something to be learned. Bring it straight down. There's the point of contact there for between the cylinder and the cone. Now the second part of this here, then we've got the cylinder in elevation. We know the cylinder position, so you can bring the center straight down to plane. But in a lot of these questions, a load of these are solved by drawing these objects beside each other. So what I'm after doing here now is, that's the cone A. If I drew the cylinder C beside it in contact, I now know then how far apart their centers are. So that's what I'm going to do here. So I'm going to just measure the width of that there, which is 30. So if I redrew that, now to be honest, I'm more concerned with where the center is rather than the right hand side. But like if I redrew that cylinder, see there, just a little bit of it. Okay, so that's my cylinder there, just redrawn. I didn't bother drawing all of it, but the center of that here is going to be the center. There's the center axis of that cylinder. Now if I brought that down here, there is the center when it's beside it. Okay, so that's the center when it's drawn beside it in plane. And now I'm going to roll it or slide it around in contact. So as that center, if I roll that around as it stays in contact here, straight down from where we know it is, that is the answer. That's what we're looking for. And we know that the radius of that is 15. I can take it from up here. So that's the so just move that camera back a bit. So I'll redraw that again. So there's the sphere in its final position, and just going to mark the points of contact. Now we know the point of contact is at the base, but it's on the lines joining the centers. So that there is the point of contact, POC, point of contact. And if I wanted to find that in the elevation, it's on the ground. Point of contact. Okay, so draw the plan of the cylinder. So that's done. Points of contact shown. So that's that first bit done. Now the second one here, you've got a cone and a sphere. And again, like I was saying the last time, almost always the answer to these is you're going to have to bisect the angles here. And you're going to be going up the center height of putting on the height of the center, and you're going to be drawing the sphere in contact with the cone when it's right beside it, and that allows you then to bring it down to plan and roll it around. And there's even a shortcut you can take there, like the horizontal distance. You don't even need to bring it down to plan and roll it around. You can take that horizontal distance from the axis of the cone to the center of the sphere. I'll look at that in a second, but that is almost, I'd say 9 times out of 10, that's one way that these can be solved. So, to draw that sphere beside the cone, I'm going to just bisect the angle between the sides of the cone and the ground. So just open the compass a bit bigger for the second 2 arcs to make it more accurate. So I'm bisecting the angle. And we know that the height of the center of the sphere is that far above off the ground. So that there is the center when it's beside it. Now I could draw it in. Look, I suppose I will. I don't need to, but I just will. Maybe it'll help people understand. So I will draw in that sphere beside the cone. So it should be in contact. No, that's enough of it in there. I don't need it all. that's it when it's beside it. Now, so the next move there then is just bring the center down. Now remember now, some people call this a ghost sphere because it's not really there, but you're pretending that it's there. So that's the center of the sphere when it's beside it. But if you roll it now back around in contact, so that's rolling the center of the sphere around. Just put arrow on that to say you're rolling it around, and we're going to bring our center down from here because we know it has to be straight down from here. So that there has to be the final center. So I'll just set the cone or set the compass there again off the front view. Now, a ball will always roll over the edge of a cone. Okay, so a ball will always roll and cover the edge of the cone. So really, I'll just try and put in a few dots here on this to say that that's dotted there because the sphere is rolled over the edge of it when you're looking down from above. So complete the projections by locating the sphere and plan, that's done, and find the point of contact between the cone and sphere. And I was going to do that anyway. Now, when we drew our ghost sphere here at the side, I'm going to find the point of contact to the ghost sphere. So 90 degrees in from the side of the cone, that there is the point of contact when the sphere is beside the cone. Okay, but that's not the final position. So what you've got to do there then is bring it down to plane. Okay, so that's not the final position, so I'm not going to mark it as point of contact. You've got to bring it down to plane. That would be the point of contact when the sphere is beside it, and then you roll it around again, same as we did. So just set your compass. Roll that around, and the point of contact is always on the line joining the centers between spheres and cones and stuff like that. It's always on the line joining the centers. So that there is the POC for point of contact, and I'm going to bring it up now to the elevation. And we know the height of it is here. So it's that height. So that there, POC for point of contact in plane, point of contact at elevation, because that it had to be that height. So when you roll a ball or a sphere around a cone, the height stays the same of the point of contact. So that's that done. Now the third question here, to be honest now, these are pretty easy because they're ordinary level questions from before. So for higher level students, they should be okay. Now you've got a cone, you've got a sphere in front of it. So there's the cone. And you've also got a sphere, which is a football, at the right of it. So I'm going to do this one first because it's kind of repeating what we spoke about earlier on there. I'm going to just bisect the angle between the side of the cone and the ground. So just take an arc out and some arcs again then. Now there's several ways of doing this, because another way of doing it there, I know if the sphere is on the ground, I'll find it first, but I'll just talk about another easy way of doing it. So bring up the center. There's our solution. That's the center there. But because we knew the radius, another way I could have done it, I could have just projected it up, measured the radius there. So I didn't even need to bisect the angle there. It's just because you use it so often, I kind of just do it without thinking. I could have just measured up the radius, stepped it up there. So there's the sphere, and I'm going to just throw in the point of contact as well. It's a good habit, even when it doesn't ask for it, I think it's a good habit to put it in there. So 90 degrees off the side of the cone. So there's the angle of the side of the cone. Just twirl the set square and 90 degrees in. So that here is POC, point of contact between the sphere and the cone. And if I just project that down, then that's my point of contact in plane, POC. Now, the other one then is I'm just dealing with that sphere that's in front. So sphere B, which is in front. Now again, that goes back to what I was talking about there up above earlier on, about, just showing the camera up there for a second, drawing the sphere at the side of the cone and then moving it down and around. So it's only doing that again. So I'm going to bisect the angle between the ground and between the horizontal plane and the side of the cone. So the center of the sphere is on that line. We know that the height of the center above the ground is here. So that there is the center of the ghost sphere when it's beside it. Again, do you want to draw it? There's no benefit really to drawing it, I guess, unless we're going to get in the point of contact, but I will stick it in anyway. Okay, so there's my sphere there, and I'm going to bring down the center to when it's beside the cone. So that's the center of the ghost sphere, or the imaginary sphere, when it's at the side. Roll it around. Now again, I was saying earlier on there's a shortcut there. If you take that horizontal distance from the center axis of the cone out to the center of the sphere, you can skip the bringing down and rolling around if you wanted, because you could have just taken that distance and marked it straight. It just skips like a stage or two if you really understand what you're doing. So this here is the final center for that basketball. Now guys, it's awful important to have a really good sharp point on your compass lead, which I need to sharpen mine a bit up now. It's not the greatest. Okay, so that's the final position of the sphere which would mean that the cone here would be dotted. I'll just stick in a few dots there freehand behind, because a ball always rolls over the base of a cone if they're in contact. Sorry. So finally, point of contact again. So get the angle of the size of the cone. Then twirls that square. Come in from the center. That is the point of contact with the ghost sphere. So I need the height of that in a second. So I'll just, oh no. Actually, because it's right in front, I know that that's the final point of contact, because we know it's in front. And then I'm going to bring that down to plane, roll it around, and that there is my point of contact. Now obviously it's down on the underside of the ball. Okay, so point of contact between the cone and the sphere. Okay, so that's everything done there. That's question 3 done. Now, slightly different here. These are supposed to be water features, but they're spheres. Okay, they're balls, they're spheres, whatever. And we know the radius of the second one. So this is, again, you can, if you take the radius of that, so anywhere at all here, if it's sitting on the ground, you can just swing an arc and go tangent to the top of that arc there. So that's the height of the center. It's the same as if I measured that and stepped up that height and drew a line across. So that's the height up of the radius of B. Now, when two spheres are in contact, it's kind of hard to see there. So if I sketch this above here, if you've got a sphere here and another sphere there in contact, sitting on the ground, if you add their radiuses, that's how far apart the center is. So the radius of the big one, there's a few different ways that I could do this now. You know, you could do it using maths by measuring that, by measuring A and measuring B and adding them. But what I normally do there is just extend out a horizontal line, and I'm going to add the radius of B horizontally out here. So I'm adding the radius of B horizontally, and then I'm going to swing A plus B down. And that there is the center that I've been looking for. So there's the center for my sphere. Now again, there was, and because you see a lot of the time you won't have this in plane, that I could have easily just projected this up, like I could have projected up that center there and had it as well, because we knew the height of it. But you know, for higher level, you'll be given the radiuses of the spheres, but you'll be finding it. So I'd rather take the longer approach. So there's our sphere. So I'm going to just set my radius to B. And it should be just tipping the side of it there and tipping the ground. And like I said earlier on, point of contact is always on the lines joining the centers of the spheres. So That there is the point of contact between the two spheres in elevation, and when I bring that down, it's here, just in between the two of them there, on the line joining the centers and plane point of contact. So draw the plane elevation, and then they ask for the plane elevation of a third sphere C that's in contact with both of them. Okay, so again, how you're going to be doing this there is, that's sphere C, and that's sphere, let's say, another turn the wrong way here now, because the big one should be on the left. But basically, if you've got two spheres in contact, so if I say like that's A and that's B, and I want to put C in contact, basically you draw C at the side of A, and you draw it around at the side of B, and you roll it around, and that's how you find the center. So you draw that small one beside A, beside B in the front view, bring it down the plan, roll it around, and that's how you find, that's what we're going doing. So to find, we know if C is sitting on the ground, if I was doing it by maths, I'd be just measuring the radius here, but I don't particularly like doing it by maths, but it's radius 8. So look, I will do this by maths, because that C is radius 8, you can just measure up 8. That's the height of the center above the ground. So like I was saying earlier on, then I want to add 8 onto radius A, and I want to add 8 onto radius C. And I just did it horizontally because, no, again, look, I could have measured that radius there and measure that out and measure that radius up, you know, to get that information that I've done so far. So that's the ghost sphere when it's beside it up in the air. So I want to swing it down now until it's sitting on the ground. So that there is the center of the ghost sphere for C, in contact with A. And over here at the other side, I'm going to swing this down here, and that there is the center of the ghost sphere C in contact with sphere B. That C there is for center, but so this is the center of the smaller ghost sphere beside it. So again now, I'm going to be bringing them down to plan, rolling them around. So bring them down to plan. Now I could draw those spheres in there as ghost spheres. I could draw them in, but I may need to actually for the points of contact if they look at it, if they look for it. So I'll draw the sphere first in it, and I'll draw them in if I want to then for the points of contact afterwards. So roll that ghost sphere around A, then roll that ghost sphere around B. And that there, where they cross, that is the answer basically. That's the point I'm looking for. So I'm going to be setting my compass here to radius for C again. and I can draw this in now, and it's final. I can draw that in pretty heavy. Now it's going in underneath, so I'll just heavy these in here now. A small sphere or a small ball always rolls far in under a bigger one, not so far underneath sphere B here, because they're almost the same size, so it doesn't go as far under it. So that's it drawn in its final position in plane. Bring it up. And I can now draw it in its final position in elevation. Now when you're drawing spheres that are small, it's very important that the lead and the point are the exact same distance. You know, sharp lead as well, but they need to be the exact same length, because if the lead is longer or shorter than the point of the compass, it's going to keep slipping. So now that is the sphere drawn in the final position. So this is very small now. It's a bit small, to be honest. It's a bit tricky. I'm going to find the points of contact now as well. So if I join that's the height of the point of contact between A and C. So since the point of contact is always on the line joining the centres, if I join A to C over here and take that height of that point of contact across onto it, that there is the point of contact between A and C. And likewise at the other side, if I join the center between sphere C and sphere B, this is sphere B and that's sphere C. So if I join centers, so that there is the height of the point of contact with the ghost sphere, so I can bring that height across. And when I join the centers, then and we know that this is the height of the point of contact, so there's my point of contact. So you can see there's 3 points of contact there between all 3 of them, and then in plan to get those 2 down, just join the centers. Point of contact between the spheres is always on the line joining the centers, so that's as you would expect, because they're hardly crossing over. It's just right there. And between C and A, join the center C to the center of A and bring it down from elevation. And there is 1, 2, 3 points of contact in plan. But they're very small now, it's very precise for this. But the ghost spheres, guys, of drawing it to the side and rotating it around in plane, like that is what you have to understand. You're drawing it at the side, bringing the center down, rolling it around in contact, doing the same with the bigger sphere A, bringing it down to plane, rolling it around. And where those 2 ghost spheres, because they're both the same size, so the 2 of those spheres sort of merge into one at that position there then, and that's how you find it, and then you bring it back up. Can't emphasize how important it is to kind of understand the thinking on that, because you know it's something that comes up a lot. So yeah, best of luck with that, Sloan.